Okay, so welcome everybody. Sorry again with the bizarre difficulties with Google. Really, it's not us. We totally were trying to get going on time, but anyway, we're here. We're not even going to go that. Go there. Thank you everybody for joining us. Who's here tonight? My name is Andy Shaner with the Lunar Planetary Institute in Houston, and this is tonight's MyMoon CosmoQuest X Hangout. With me is Nicole Gugliucci with CosmoQuest, and of course our host Brian Day, who's with NASA Ames Research Center, and he is the Education and Public Outreach Manager for the LADEE mission to the Moon, which he'll be we'll be chatting with him tonight about that, and he's also the Education and Public Outreach lead for the NASA Lunar Science Institute, which is also based at Ames, and so maybe you might want to ask him something about that tonight as well. But just first of all, again, thank you everybody for coming, and thank CosmoQuest for partnering us with us on these hangouts. There certainly are a lot of fun. If anybody tonight has a question for Brian or a comment, you can do so in the comment or in the. If you're watching us from from the event page for this hangout, you can pose a question in there. We'll get that question, pass it on to Brian. You can also ask them through Twitter with the hashtag MyMoonLPI or at MyMoonLPI, either one, and we'll get that question for you. If you're watching us through YouTube, you can also post a question in the comments, and we'll pass that along when we get it. And just to let you know, the questions kind of come in kind of slow to our aggregator, so I apologize if we don't ask it right away. But when we do see it pop up, we will get that question passed on to Brian for you. All right, so without saying too much more, I'm going to hand over to Brian. So Brian, thanks for joining us tonight, and tell us what's so exciting about this new mission called LADEE.
Well, there's a lot of stuff going on now that's really very exciting. LADEE is about a 10-minute walk away from me at this moment. It's in the final stages of preparation before we pack it up and ship it off to the East Coast for launch. We're scheduled to launch right now. Our launch window opens on September 5th. But the whole concept, LADEE stands for the Lunar Atmosphere and Dust Environment Explorer, and boy, is that a loaded phrase right there, because, hey, when I went to school, I learned that the moon doesn't have an atmosphere, and the idea of, a lunar environment was kind of like jumbo shrimp, a real oxymoron. And but in the last few years, we have found that the moon that we thought we knew from the days of Apollo is very, very different than the moon we are now discovering with this new generation of robotic lunar explorers. So from LRO and L-Cross and Grail and Artemis, and we have had a whole new moon revealed to us. And so now we are about to go explore the lunar atmosphere, something I grew up learning does not exist. So my God, that's just got to be exciting.
It is. No, it really is. I think, like you said, the idea of a lunar atmosphere is something that I think pretty foreign to a lot of people. It was to me until just a few years ago. But is the idea of an atmosphere or an exosphere on the moon, is it really quite old, or were there hints to the possibility in the past?
Yeah, we did get hints back during the Apollo days. Some of our Apollo missions did detect really small trace amounts of certain gases. But the picture we got was very, very fragmentary. So we realized that there were very small amounts of gases, but we didn't really know what the full composition, we still don't know what the full composition of the lunar atmosphere is. But even before Apollo, we got some really interesting hints of something strange going on. There were these surveyor landers, robotic landers that landed on the moon, and as they would look toward the horizon, when the sun was just below the horizon, they would see these strange glows, this glowing feature above the horizon. Now, if the moon's sky was empty, there would be nothing for the sunlight to be reflecting off of. But here was sunlight reflecting off of something. And so That gave us a clue that there was perhaps dust somehow being levitated up above the surface of the moon, catching that sunlight and streaming it back. So we have early clues that the moon has some sort of an atmosphere and that there may actually be an active dust component, dust lofted into that atmosphere.
So how does it get up there? And why doesn't it just fly away?
So the dust, how does the dust get up there? And that's an excellent question. We have several thoughts. First of all, it could be lofted by meteoroid impacts. The moon is constantly being bombarded by meteoroids, most of them small, what we would call micrometeoroids, but that in and of itself could be enough to kick up dust. But one of the things that we're also understanding is that the environment of the moon is charged. There's an electric charge to the moon, and it varies between the daytime side and the nighttime side. And what we think may be happening here is that we may have electrostatic levitation of dust particles off the surface of the moon. That's certainly a $20 term right there. But for those of you who might be school teachers or even parents, this is a real fun thing to do. You can demonstrate electrostatic levitation by blowing up a rubber balloon, tying it off, rubbing it on your shirt, and then holding it over a kid's head or your dog or whatever, and you'll see that hair just being raised up. That's electrostatic levitation, and we think that something similar, minus the dog, may be happening on the moon. And so looking at this charged environment on the moon, that might be enough to actually loft these dust particles high into the sky of the moon. We got one other really interesting clue of that. That was back during the Apollo missions, and on several occasions you would have astronauts in the command module orbiting the moon, and they would look out the window, and again, with the sun just below the horizon, they'd see these beautiful jets and streamers rising high up into the lunar sky, even up to the level at which they were orbiting. And again, that's not very consistent with an empty lunar sky. But what some people are speculating is that these dust particles may get lofted tens of kilometers high up into the lunar sky. That's one of the things we want to investigate.
Okay, great. So what?
Why
it's not
do
the kind of atmosphere you can breathe, right? So yeah, why?
Okay.
What's scientifically cool?
Yeah, let's talk about this atmosphere a little bit, because it's really easy to get the wrong idea. Here on the surface of the Earth, if at sea level you were to take a cubic centimeter of Earth's atmosphere, it would contain about 10 to the 19th molecules. If you were to do the same on the surface of the moon, your sample would contain about 100,000 to maybe a few million molecules. Now that sounds like a lot, but it's not. That's actually a really good laboratory vacuum. As a matter of fact, the atmosphere on the surface of the moon is very similar to the outermost fringes of the Earth's atmosphere where the International Space Station orbits. So when our astronauts do a spacewalk at the International Space Station, they're experiencing an atmosphere that is on the order of what we find on the moon. That sounds totally inconsequential, but it's not. It turns out that atmosphere of the moon is energized by the sun, and it actually glows. Now, you may not have noticed the glow of the moon's atmosphere, but that's because it's always right next to the big, bright moon. If somehow you could remove the moon and leave its atmosphere behind, then from a dark sky, you'd be able to look up, and just with your unaided eye, you'd be able to see that glow of the moon's atmosphere.
Oh, wow, it's that bright.
Yes, it is. So that's kind of neat. That's something new. And the technical term for this type of atmosphere is a surface boundary exosphere, which means it's a really, really thin atmosphere. But the reason it matters is because this type of atmosphere that the moon has, this surface boundary exosphere, is actually probably the most common type of atmosphere in our solar system. The moon has one, Mercury has one, the larger asteroids, many of the moons of the giant planets, even some of the Kuiper Belt objects, distant icy worlds out beyond Neptune. This is the most common type of atmosphere in our solar system, and we know next to nothing about it. But we happen to have one right next door. How lucky is that? So that's why this is really cool.
So what kind of tools does LADEE have on board to study this atmosphere?
Very good question. LADEE is carrying 3 different scientific instruments. It is carrying a mass spectrometer as well as an ultraviolet spectrometer that will help us actually sniff out the stuff that we're flying through. Again, the whole idea of LADEE is when it gets to the moon, it's going to go into orbit around the moon, but it's going to drop down low. It's going to drop down low and actually fly through the atmosphere. It's going to sample it. And our goal here is to see what the composition of the atmosphere is, what its structure is, how that changes over time. So we'll be sniffing out this atmosphere with the neutral mass spectrometer and with an ultraviolet spectrometer. But then also, we're really interested in that idea of dust. If there is dust being lofted into the lunar sky, if so, how much, and is it charged? And so we also have an experiment on board, a dust detector, that will help us understand those very questions. So there are 3 scientific instruments on board LADEE that will do that. We're carrying one other thing that's going to be of great interest too, and that is the Lunar Laser Communications Demonstration. When we do missions into deep space, to the moon or beyond, and we're sending data back by radio, those transmitters on the spacecraft are very low power. They have to be because we can't carry a lot of weight. And so because they're so low power, that means we have low data rates. Now, radio frequency communications on LADEE will be downlinking our radio data at a rate of 128 kilobits per second. Okay, that's like a really old modem.
I remember that.
Yeah, yeah. But you know, that's kind of what we have to live with across these vast distances, and really low power radio. But one of the things we're going to be trying out is a whole new concept of, instead of sending the information by broadcasted radio waves, we're going to try sending information via a laser. And so instead of going at 128 kilobits per second, we're looking at the possibility of 622 megabits per second.
Oh, wow.
We're talking about the possibility of bringing broadband communication speed to our space missions. That's pretty cool. So that's the 4th thing we're taking along. Again, it's a technology demonstration.
That'll make some, I know my background's in radio astronomy, and a lot of people want to put radio telescopes on the moon, and that would make them very happy.
Yes, it would.
And you didn't need the radio waves to transmit.
That's right. There are potentially very many benefits to doing something like this. So it's very exciting.
Cool.
Yeah, so I remind everybody, if you've got a question for Brian, I think he's given us a lot to ponder just in the first 15 minutes. You can do so through Twitter. Use a hashtag MyMoonLPI or @MyMoonLPI. We can pick that up. Or you can use it in the comments section if you're watching us on YouTube. You can also use it in the comment area if you're watching us on the Google event page for this Hangout. Brian, so what is there? So a lot of these moon missions to the moon, starting with LRO and LCROSS, within the past 5 years, or sit in it partly to really help us prepare to send humans back to the moon. How does LADEE contribute to that?
Well, in a number of ways. First of all, one of the concerns that we have had in the past when we start thinking about human operations and mechanical operations on the moon is this whole issue of dust. The lunar dust is very, very angular. It is very, very abrasive. And if it is electrostatically charged, then it could really stick to stuff. So understanding this dust environment of the moon is very important. But something else we have to think about is that, again, this atmosphere of the moon is a very thin, fragile atmosphere. Not just the United States, but countries all around the world now are planning lunar missions, be they manned or robotic. But we can expect to see increased activity on the moon by a long shot. Thrusters firing, perhaps people exhaling, belching, whatever they may do. And all of that activity has a very strong potential to overwhelm this very thin, fragile lunar atmosphere. So if we're going to understand the lunar atmosphere, the time to do it is now before we change it.
Very true.
I never thought a human burp would make such a big impact, but you're right. I mean, if it's such a low density atmosphere, exosphere.
Yeah, I mean the firing of a thruster on a lander, it can release a huge amount of gases relative to the total content of the lunar atmosphere. So this is a really good time to do this exploration.
Is it possible that let me ask this real quick, and then we have a question from the folks out there watching. But one of the problems sometimes is that missions have a certain lifetime. They don't last forever. Is there any? Does the science team hope that LADEE can get enough information? Maybe not all the information we could possibly get, but enough to be able to inform us about before we send astronauts to really start messing things up?
Yeah, you're right. We do have a limited lifetime. LADEE's science mission has a 100-day duration. So we're not up there for years. We're not up there for a long time at all. But we will be up there for a variety of events, including a number of meteor showers. And so we're also, it's interesting that we're up there right around the time of solar maximum. So it'll be really interesting to take a look at how changes that we may detect in the lunar atmosphere correlate with energetic events on the sun.
Interesting. So that question from Vance: where does the moon's atmosphere come from?
Wow, that is an outstanding question, and that's one we're hoping to answer. We actually, it's not a simple question, and therefore there is not a simple answer. There are probably multiple sources for the lunar atmosphere. So think of, so right now we've got a conference going, or a virtual conference going on. We call it a virtual workshop about lunar volatiles, and there's lots of volatiles on the moon. And but those relate to an atmosphere. So where could the atmosphere come from? Well, imagine meteoroids and comets slamming into the moon. Those could certainly give rise to a lot of gases. But you also could have, and we do realize that there's outgassing from the interior of the moon. There's also the solar wind coming from the sun. You can actually have sputtering of material, erosion of material off solid surfaces on the moon from radiation and charged particles in space. You could have chemical reactions going on the surface of the moon. So there are a variety of potential sources here. What is their relative importance? We don't know. We can hypothesize what a number of these sources could be, but we've really got to get down into it and really examine the moon and see what all this atmosphere is made of and see how it varies over time. One of the things I'm most interested in, and I hope to involve maybe some of the listeners here, is the whole question of what role do meteoroid impacts play on the moon in terms of generating an atmosphere. And believe it or not, that is something that your viewers today, you people out there, all of you, you can participate in. You can help us figure this out. This isn't just our mission. Don't just sit there and watch us. This is your mission too. Participate. Get involved. Help us do the science. And if any of you are curious, I will be more than happy to tell you how we're going to go about doing that.
I am.
Oh, good. All right. You know, Andy, one of the, I didn't put together a whole lot of slides, but slide number 13 might be a fun one to watch if you could possibly bring that up.
I'll do what I can.
So what we're going to take a look at here is we're going to take a look at a flash on the nighttime side of the moon caused by a meteoroid actually hitting the moon.
Is this the one from a few days ago?
This is not. This is even before that.
Okay.
But hopefully you people have heard on the news that we had a really bright one. The one you're about to see is not nearly as bright, but there was a one that just came out where if you were looking up just with your eye, you didn't need a telescope or binoculars. If you had been looking up at the right time, you would have seen that flash on the surface of the moon. Okay, something like that's pretty rare.
Yeah.
But the one we're going to be looking at here is actually very common. So is that something we can bring up now, Andy?
You should see it.
There we go. Okay, whoops. Saw it for a second.
You can, if you can click the little window at the bottom, and that'll bring it into focus for you. Andy, I think if you have it clicked, then the audience should see it as well.
Yeah.
Okay, so is the audience seeing it now? So it should be running.
Oh, I see it.
Yeah, so there's that little flash, and this is a video loop, and you can see that little flash happening down there in the lower right. And you can see the bright daylight side of the moon up at the top, and the nighttime side of the moon down there. So this is something that was actually recorded by an amateur astronomer, George Varos. And it turns out that these flashes of meteoroid impacts are really best recorded using a telescope in the 8 to 14-inch diameter range. Now that's something that a lot of amateur astronomers have. There are a lot of these out there. And so what we're hoping to do is get a network of people out there watching the moon during the LADEE mission. And the ideal thing is, so with the appropriate video camera, if you go to the LADEE website, www.nasa.gov/LADEE, you'll see a link about how you can participate. And that will get you started. And we'll get you all the information you need. But one of the wonderful things is if we can get enough people watching so that we can record some of these impacts, then ideally what we'd love to do is be able to correlate any changes that LADEE's instruments see in the structure and composition of the lunar atmosphere with some of these impact events. That'll help us understand the role that these impacts play as a source for the lunar atmosphere.
Gotcha. Cool. Yeah, I'm seeing you have several. In addition to the telescopes, you're looking for people to do meteor counting.
Yeah,
as well.
That's right. Very good, Nicole. So let's talk about that for a little bit. If you don't happen to have an 8 to 14-inch telescope. That's not a showstopper. It turns out that the majority of the impactors hitting the surface of the moon are really very, very, very small, on the order of about 1 micron in diameter. And those would never create a flash that would be bright enough to be observed from the Earth. But because the Earth and Moon travel together through space, they encounter streams of debris together. And when even a very small piece of debris hits the Earth's atmosphere, it can become evident as a meteor. When you look up in the sky and you see a typical meteor in the sky at night, the solid object behind that streak of light in the sky, the solid object causing that, is typically about the size of a grain of sand. So even a very, very small object can become very evident as it interacts with our atmosphere. And again, because the Earth and Moon are traveling through these streams of debris together, this can give us important clues. If people go out during the LADEE mission and actually do meteor counts, count meteors in our atmosphere, and see how that number varies night to night, that can give us clues as to what's happening on the surface of the moon at that time. And again, we can see if we can correlate changes that we see in the activity in our own sky with changes that LADEE is seeing in the atmosphere. It's interesting to note that when that big, bright meteoroid impact happened on the moon recently, we also had a number of deep penetrating fireballs in the sky here on Earth at night. So there may have been something really interesting going on there. So even if you do not have a big telescope with a video camera on it, you can participate. And as is the case with almost everything these days, there's even an app for that. So our good friends at the NASA Meteoroid Environment Office have come out with Meteor Counter. It works on iPad, iPod Touch, iPhone. It even works on Android. Hooray. And this is a great, great, great tool. It allows you to go out. You go out under the nighttime sky. And the great thing about your smartphone is your smartphone knows where you are, and it knows what time it is. And so you stand out there under the sky with this app running, and you've got a little screen. And you simply tap on your screen every time you see a meteor. You tap on the right-hand side for a bright meteor, on the left-hand side for a dim meteor, and in between for an in-between meteor. And every time you tap, it records where you are and what time it was, and based on your tap, how bright it was. At the end of your observing session, it then uploads all that information to NASA's database. So just going out, and the beautiful thing about meteor counting, is the equipment requirements are essentially nothing. You do not need a telescope. You do not need binoculars. Just your own eyes will do fine. However, I do recommend a reclining lawn chair. You might as well be comfortable. But the requirements are minimal, but the data can be valuable. So just by going out and making these observations, you become a part of the LADEE mission science team.
That's really cool. See, I don't have a very large telescope either, but I recently used one of the dark sky apps to just sit there and tell what stars I could see in the sky. And so it's so easy to sit there and actually add to this database. So it's really cool.
Excellent, excellent. So this is really what we're hoping to see happen here is people of all ages, we want to work with Boy Scouts and Girl Scouts and students and older people, and this is something it's a great family activity too. So this is how you can very simply participate in the exploration of the moon.
Now, Brian, this rating scale is fairly subjective, And I know, like with CosmoQuest, with the crater counting activities they have taken a lot of data to come up with these averages for the craters that people circle, and compared that to expert analysis. Is this program doing something similar, where it's averaging people's responses to the brightness?
So one of the things we do need to do, I mean, the data will be better with the more input we get. Mm-hmm. Okay, there will be outliers. There will be the people who may go out to do a count and fall asleep, and they may miss a whole lot of stuff. There may be people who are, well, just seeing meteors all over the place that maybe aren't there. Those are outliers, and we can statistically kind of weed the outliers out if you have enough data points. So the more people that do this, the more valuable and the more accurate the data becomes.
Yeah, I think that's what we found with moon mappers, is after an image has been looked at by some 6 or 7 people, I think the number is, it's, you know, right on top of what an expert crater mapper would mark.
Statistics comes to our rescue.
Yes. Are those magnitudes, those numbers?
Yes, they are. And so maybe we should talk about that a little bit.
Yeah.
And this may change. We have new versions coming out, but basically the magnitude scale works kind of backwards. So the lower the number, the brighter the star. The brightest star in the sky, Sirius, is about magnitude -1. The dimmest star you can see from a dark sky location is probably around +5. And so we're running a range here of, now think of Venus, like that can get brighter than Sirius, the brightest star. So we go above -1. And sometimes you can get meteors that'll just light up the whole sky. Mm-hmm. Those can be seriously bright. But again, just think of going from the brightest star that you can see in the sky, and maybe and then a little room to the right of that, so to even be able to say it's even brighter than the brightest star I can see in the sky, down to, well, that's about as dim as I can see. I just barely saw that meteor. So again, the bigger the number, the dimmer the object.
Yes.
The lower the number, the brighter the object.
And also, if it's kind of trucking along slowly, chances are you might be seeing a satellite and not a meteor. There's definitely a difference when you're sitting out there watching.
Very true. The satellites tend to move very slowly and deliberately. A meteor is going to move very, very quickly across the sky.
Yeah, yeah. But don't be surprised to see that as well. Like you could treat yourself to an ISS pass or bright iridium satellite while you're out there.
Exactly.
But those are predictable. Those are predictable. You can look up the times of those.
Exactly. But we've got a great opportunity coming up here to do some practice.
Ooh.
Because this coming August, we're going to have the Perseid meteor shower. So go out sometime around the nights around August 12th. Now, we won't be flying yet. But that's fine, because you don't want the first time you do this to be as we're really doing the mission science. It's nice to practice first. And boy, do we have a fantastic practice opportunity with the Perseid meteor shower coming up. It's going to be about a first quarter moon, so it works out amazingly well. So for the people who want to do the lunar meteoroid impact detection with telescopes, that means in the earlier part of the evening, you're ideally situated to point your telescope at that nighttime side of the moon and start getting some video going and see if you can actually detect some flashes. And that would be a really good night to look because, well, we're in the middle of the Perseid meteor shower. But then, as the night goes on and the moon sets, something interesting happens. Because from midnight on, You, as you're standing there on the ground, because of the rotation of the Earth, you rotate onto the leading edge of the Earth. You know, between noon and midnight, you're on the trailing edge. But after midnight, you rotate onto the leading edge. And just as when you're driving in your car, you get a whole lot more bug splats on the front windshield than on the back, you can expect to see more meteors in a meteor shower as you're on that leading edge, so the after midnight edge. And so the moon sets, the sky gets dark, and you're on the leading edge, and now it's time to enjoy some Perseids. So, boy, what a fantastic practice opportunity.
Definitely, yeah.
Cool. Well, very good. Yes, really cool ways to get involved. So thank you, Brian. So let's kind of switch back to LADEE real quick. And so LADEE is launching. This isn't the first time something is launched from the Wallops Space Flight Center, but it's the first time this rocket is launched. Is that correct?
There are a number of firsts going on here, and so let's see. There's slide number 11. If we can bring that up,
okay.
Let's pull that up. That's going to be interesting. But there are a number of firsts going on here. We are indeed the first deep space launch out of the Wallops flight facilities. They have sent stuff, they've done sounding rockets, they've sent stuff into Earth orbit. This is the first time we're going, hey, let's go ahead, let's go with this slide here. So it's the first deep space launch out of Wallops, and it is going to be the first time a mission has flown on the brand new Minotaur 5 rocket. So that's exciting too. There's a lot of stuff happening here. This is going to be, we talk about the Wallops Flight Facility. This isn't launching out of Florida. This is launching out of Virginia, the coast of Virginia.
Right after I moved from Virginia.
Oh, bad timing. Go! But it's right now, if we launch when we're scheduled to launch, it's going to be a nighttime launch.
Those are fun.
And you're in the Washington, D.C., Baltimore, greater, you know, the East Coast. As a matter of fact, if the weather is good, approximately half the population of the United States has the potential to be able to look up and see this launch. From Wallops Flight Facility there on the coast of Virginia, when they launched a while back a Minotaur 1 rocket at night, it was visible as far west as Detroit.
Oh.
And that is the little brother to the rocket we're going to be flying on. So this could be spectacular. And one of the things we're doing is we're working with our partners at Orbital who are supplying this rocket. We are working on putting together charts so that throughout the eastern part of the United States, you will be able to tell where to look up in the sky and to see this arcing rocket flying. Now imagine, say, standing on the Capitol Mall and watching the bright arc of a moon rocket going over the Washington Monument.
Wow.
Oh, I want that picture. So if you take a look at, now let's go to slide 11 there, Andy, if we can. This is going to show you the moon.nasa.gov website has a special link that will take you to LADEE launch events.
Okay.
And there are going to be a number of events that will be happening. We're going to have real physical events where you can go and watch. We'll also be having, of course, social media events. We're going to have all kinds of wonderful things happening. And if you go to this website here, you will be able to see where there is going to be an event near you. Also, if you decide you want to have your own event, you can go here and you can register it, and we will publicize it for you. So this is the place to go to learn about events around the LADEE mission.
All right, very cool.
That's really cool. That's really cool. Yeah, I'm thinking something Yuri's Night-ish, you know, can have a little party. Anyone. It's just
Hey,
gonna have a party.
have a moon launch party. Why not?
Yeah.
You know, if any excuse works, but this is better than your average excuse. This beats, hey, I found my tennis shoe any day.
Okay. Well, does anybody else out there have a question for Brian?
Not that I see at the moment, but yeah, send in your questions if you have any. Other than we have some people excited who asked, "Ooh, how can I get involved?" So I think we just went through a couple different ways you can do that.
Definitely, really cool stuff. I just downloaded the Meteor Counter app.
Good for you.
You're multitasking.
I hope many other people do so too.
I'm adding the links to the Google event page if you're watching it there in the comments. YouTube won't let us do that, so go check that out, but I'm sure we'll include it in the show notes after the fact. All these links. Meteorcounter.com is where you can get the app. And then if you Google LADEE, L-A-D-E-E. Oh, I have a question. Because I just saw Star Trek this weekend. have you thought of having a little promo from Simon Pegg as Scotty? You know, because it sounds like he's Lottie.
Oh, that's.
Do we have any Hollywood contacts so we could get that?
Yeah, that's an interesting idea. I will certainly pass that along at the next staff meeting.
There's got to be a Scotty joke you guys can make.
There have been a few.
Oh, okay.
Even some of the ideas for you'll see maybe at the top of the slide there. There's a picture of kind of a LADEE emblem at the top left. Some of the early ideas even did feature little dogs, but yeah, this was by vote what came out of it.
Okay. We have another question from Vance Macaulay on YouTube. Does the bugs on the windshield analogy, the reason that the lunar flash map has no pole flashes? So as you were saying, the Earth kind of plows into things a certain way. Do we see a lot of flashes at the poles? And I guess analogously, do we see a lot of meteors at the Earth's poles?
So actually these streams of debris, I am so glad this question was.
Did we lose him?
I don't know. You there, Brian?
Uh-oh. I thought it was just me.
He's so stunned by that question, he's speechless.
He was about to. Oh no! He was about to answer, and I have no idea.
Brian, he is so dramatic like that. He just stops.
No, Internet. Why do you do this? We're gonna have to wait for his answer. I don't know. I guess we can ping him back in. Hang on, Vance. Hang on, studio audience.
It will. Oh my goodness! This is a first for us.
Yeah. Do you want to? What you can do is, of course, send him another invite to the same Hangout and see if he'll pop back in, because he may not know he's frozen, or the link. Oh, there he goes. He got booted. Yeah, he came back.
Hey. Yeah, I got kicked off apparently, so
the internet gave up.
You weren't able to get rid of me that easily.
Good.
So
we're like on the edge of our seats here, waiting for this answer.
Yeah. Okay. So it's a really great question. So these streams of debris come in from all different directions. Mm-hmm. So, for instance, they don't just hit equatorially. Some of them do stream in from the north. So we have a meteor shower here on Earth called the Ursids, and those come in, hitting essentially the northern regions of the Earth because, well, that whole area is, Ursa Major. That's in the northern part of the sky. So basically, these things can come.
No.
Or did you lose me again?
I saw you pause for a second there, Brian.
Yeah, and I'm
Okay,
talking to a muted microphone.
I'm seeing everything froze. So, okay, but it sounds. I'm
The
seeing.
Ursids.
Yeah.
Yes.
So I keep getting this message that we have network difficulties. So, so wave at me or something if you lose me.
Okay.
But so these streams come in at all different directions, and sometimes yes, we will see impacts that will preferentially be on the northern area of the moon or down in the southern area of the moon. Just like we have meteor showers that are better viewed in the northern hemisphere of the Earth or the southern hemisphere of the Earth. But fascinatingly, we have meteor showers that come at us, these streams come at us from the daytime direction. There are daytime meteor showers that you would never see just looking up into the sky because, well, it's daytime and you can't really see meteors during the daytime typically. But radio amateurs, ham radio enthusiasts, have for years been aware of meteors in our atmosphere and how they can hear them. They can actually use them to bounce signals off those ionized columns of gas. And so if we want to get a really complete picture, we'd love to get meteor counts during the daytime too. And the people who are uniquely...
Don't!
Right?
You froze again. But yeah, what he's saying about amateur radio ham operators is you get these phenomena called whistlers and all these other things that even if you have a radio, an FM radio that you can put between stations during a meteor shower, you'll hear a more distant radio station pop in and out as the meteors create that ionized trail. So that's another way you can kind of listen for meteors while he's frozen. But I'm looking at the map. There's I found it on ABC's website, but there's a map of flashes on the moon that was posted on May 18th, and it really looks like the poles are missing, but I think that may just be an effect of you can only see a larger area in the middle, and that's why they're not detecting those other ones. That might be my supposition on that one. If you guys check out the CosmoQuest channel, we posted the weekly space hangout from Friday where we talked about that big flash, and I think we even gave the RIN deck, or not the RIN deck, the exact time of the flash. So if you have video, we have the time on that broadcast. I'm sure these guys would love to see it.
Okay. Well, if Brian pops back up, and I'm sure he will, we'll go ahead and I think we'll wrap this up.
Okay.
But we'll give him a chance to kind of say his last piece.
Yeah.
Before we get going. But until he comes back up, just want to let everybody know that our next MyMoon CosmoQuest Hangout is scheduled for June 11th, and we'll be speaking with Dr. Sarah Noble, who actually has a joint appointment between NASA Goddard and NASA headquarters. And so, in addition to the moon research that she does, she's also an artist. It has some pretty cool art work that she's done. A lot of it with the moon and Apollo human exploration. So we'll chat with her on June 11th. So check that out. And CosmoQuest has some stuff coming up, Nicole. If you wanna share those.
Sure. Today is Tuesday, which means tomorrow is Learning Space. It's at 4 p.m. Pacific. We'll be talking about astrotourism with Rick Feinberg. Hi, welcome back. And Friday is the weekly space hangout at noon Pacific. So come get your roundup of this week's space news. I will be home, or at least in the office this time, and not traveling. So we'll have a show.
Great, thanks, Nicole. Brian, we were just saying if you so you were talking about ham radio operators can tell when there's a meteor. So Nicole filled in for you.
Thank you, Nicole.
I think quite nicely there at the end to finish that up.
I hope. Yes, there was actually something I knew something about.
The network does not seem to be my friend today.
So what we'd like you to do, Brian, is go ahead and I'm going to give you a minute or so to think. Just kind of think about kind kind of what's the parting shot you want to leave everyone with? Um, and
Oh,
and we were just kind of wrapping up stuff here. So go and think about it for a minute. And Nicole, I want to ask you something too. But I think this past Sunday there was like you had like a 24-hour
Oh, that's coming up.
hangout.
That's not that hasn't passed yet. Yeah, we are doing that June 15th and 16th. Pamela Gay and I will be doing a 24-hour hangout-a-thon as a fundraiser for CosmoQuest to keep our programmers paid and fed so we can keep the project going. We are looking to get a host of guests. We're going to have science guests. We're looking to get musical guests. We're hoping to get some really famous guests. I can't make any promises except for the people who've already RSVP'd. We're going to have Phil Plait. We'll have Fraser Kane. It'll be me and Pamela. And I don't know, Andy, if you've been pulled into this madness yet. So we'll have a, oh, I'm sure you will be. You will be. We'll have a 24-hour broadcast. You get to see Pamela and I go absolutely nutty on air. And we'll have lots of really fun activities and guests. So that's June 15th and 16th. We've created an event for that. We've created several events for that. Hangouts are limited to 4 hours, so we'll have to keep switching the video feed every 4 hours. But yeah, that's it. That's that.
Well, I guess it'd be fun to watch these sleep-deprived and caffeine-hyped Nicole and Pamela, if if nothing
You've never
else.
seen us at Dragon Con. It's kind of like that.
All right, Brian, what would you like to say to everybody before we sign off tonight?
very good. Thank you all for being here. And I have to say, the moon is not what we thought it was. The moon has a dynamic environment. The moon has an atmosphere. It has volatiles. It has water ice. It is an active, dynamic place. This is not your father's moon anymore. And you can help us explore it. Most of what we thought about the moon was wrong. And we are going to rewrite. In fact, if you've got a textbook about the moon, it's out of date. It's wrong. So we are rewriting it. We are learning so much more about the nearest Earth object. And it is your opportunity to be part of this really grand adventure. Come join us. Help us explore the moon.
I couldn't have said it any better, Brian.
Thank you, Brian. You're awesome.
Thank you so much.
Yes, thank you, Brian, and thank you, Nicole, and thank you all for joining us and for being patient and sticking it out with us. Tonight was just oh man, it was just a fantastic night of glitches. That
I like to think that Google Hangout's becoming more popular and that maybe they're under a little bit of strain, and that's why we've been having some issues lately. So that's what we're going with.
We'll go with that.
Yeah.
All right, well, hope to see everybody again on June 11th with Dr. Sarah Noble, and then, of course, everybody hanging out with CosmoQuest. So good night, and we'll see you all later.
Thank you very much.